All right, everybody, welcome to the video for lesson number 2 on how we deal with these rational exponents. So one of the things that we learned was all the rational exponents have this rule of exponent over root. So I know when I see this fraction in the exponent, the numerator is the exponent, the denominator is the root. So if I want to rewrite 64 to the 2/3 power, I'd rewrite that as the cube root of 64 all to the second power. And again, I know you could just type these in the calculator. The point is to try and do some of it without, so you know what your rules are. So if we know that the cube root of 64 is 4, this is 4 squared, which makes the answer for number 1, 16. I can do the same thing here for the 125 to the 2/3 power. So I can rewrite this as the cube root of 125 squared. The cube root of 125 is 5. So we have 5 squared, which is equal to 25. The third one deals with the negative exponents. As soon as I see a negative exponent, I'm going to rewrite this expression as its reciprocal and make the exponent positive. Then I could deal with the denominator there. So I have a 4th root of 16 all to the 3rd power. Well, the 4th root of 16 is just 2. So that becomes 2 to the 3rd power, which becomes 1/8. Not too bad. Again, you can check all of these right in the calculator because they're numbers, no variables. Number 2, it says explain why 5 to the 1/3 is the same thing as the cube root of 5. This is actually a Regents question. So to explain this, I can say 5 to the 1/3 power equals the 3rd root of 5 to the 1st power because of the rule exponent over root. That is a good enough explanation for me. Number 3 says to rewrite this expression and determine what a is. So just like we did in lesson 1, I'm going to deal with what's in the parentheses first. So if I subtract my exponents, I'm going to get w to the 4th power all to the 1/2 power. Because -5 minus -9 becomes a positive. So then if we multiply those exponents together, I get w squared. Therefore, a equals 2. The next one says, let x be a positive number, and it says Maria claims that these two expressions are equivalent. Explain Maria's mistake and correct it. So when Maria rewrote this here, she took the 4th root of, the 4 to the 1/2 power. This 1/2 power is only on x. So the x to the 1/2 is equal to the square root of x, but 4 is not to the 1/2 power. That's Maria's mistake. So if we correct Maria's mistake, 4x to the 1/2 power would be written as 4 square root of x. Number 5 says rewrite the following expressions in exponential form, which two are equivalent to each other. So this has a 2 in here, even though it's not written, and an exponent of 1. So this would be 5 to the 1/2 power. This would be 5 to the 2/3 power using the rule of exponent over root. There's a little 2 in here. So this would be 5 to the 3/2 power, right? Remember, exponent over root. And this last one would be 5 to the 2/3 power. So we could say the second one and the 4th one are equivalent to each other. We can even check that in the calculator. Number 6 says, is it true that these two expressions are equivalent? Explain how you know. So we could use properties of exponents to show this. So I could say 4 to the 3/2 power is equal to 4 to the 3/2 power. And the reason why is the rule is power to power are multiplied. So if we multiply 1/2 times 3, because of the commutative property, I know that's the same thing as 3 times 1/2. So we could say these are equivalent expressions. Again, we could check them in the calculator because there's no variables. Hopefully this short video helps as you're moving forward and doing your homework. Best of luck, and I'll see you all tomorrow.